Hello everybody, I like as promised give you an update on the original version of Daniel Nunez's ABHA Coil. So Charles did provide me with the ABHA Coil, and let's compare it to that's a coil from Flash Grower. So the first obvious thing we see here is dimension change. So this is a smaller coil than this one. The second obvious difference is that I see more stranded wires here compared to the one on Flash Grower's coil. So I have as well both sides A and B, input A, input B, and so on, as it is here on Flash Grower's side. I measured the resistance of this coil. It's identical on each coil. It's counter running or the clockwise running coil. They have both 13 ohm. So the wire length is identical on both sides. So they're good things. So now let's see if this coil performs in the same way as the one from Flash Grower. I have done some tests before and they were a little bit different. And I see if we can add some more clarity about the performance of this coil compared to the other two coils I had before. Having the system set up in the same fashion as with the other coils, we see here a complete different picture. What I can tell you is that the power in the coil, that means around the coil, not to the load, is quite high. We have at the moment around 13.5 watt input, but we have around the coil here peak to peak about almost 5 kilowatt if you want. However, that is not reflected on the load. The load here is on 4 the voltage and peak to peak here on 2. That means that the power distribution in the same way I did set it up before is extremely bad. So there is actually no power dissipated over to the load and everything is retained within the coil. Now let's just go through the frequency to see what influence that has. When we go up a bit of frequency, how that's going to change. You see now the light is diminishing. So the coil makes a noise, you can hear it. At 5, 6, 5, 7 there's almost nothing going on, but also in the coil itself the power diminishes, and here we go very, very low down. Yeah, that is about 8 watt. It seems that this coil has a much higher reactance, that means it resists current flow dramatically, and the load here, as you can see, is not taking anything at all. Of course now it's come a little bit more, it's about almost 2 kilowatt peak to peak coming in now in here, and very, very low 6 watt input. However, we need to put that on the load, so that is a challenging task to do. In the configuration I had it before, that's not working on this coil at all. So that has to be completely different. But as you can see, doesn't matter what frequency I use. 3 on 4, 3 and 1 is input side, 4 and 2 is output side. So we need to focus on 2 on 4 and on 2. We want to see this value, the opposite to 3 and 1, so we can actually more power transmit actually over to the load side. Currently that is not the case. Let's go up further in the frequency. As you can see, there is no illumination going on anymore. But still the coil is circulating a lot of power inside. So we have to find a way to take the power outside. But you see the same phenomena, you see still the same peaks here. The same peaks here coming in at a very small fraction. Let's see if we can get a better picture on this one. 3. So 3 here, green, that's our current on the output side. And here, there we have the split where we have a drop in the line, it's almost to the top. So that is actually quite good that the current is aligned here on that level. However, it doesn't help us because it weighs quite a lot, so we have to wait a full 360 turn before the current is actually hitting again. We don't want that. We want to have it hitting every 90 degrees so that we get actually the power. We need to have the 90 degree lacking of current to the voltage in order to use the power. Currently we are having 4 times less power propagation compared to the wave of the voltage here on the display. So that needs to be aligned. That's completely out of line with power the way we can use it, going more up in the frequency, but the picture stays the same. As you can see, it just changes the frequency. It narrows the band, that's all it does, but nothing is happening on the load. There's also nothing happening here that I get a different picture on frequency response in the coil. So the coil is quite static. It doesn't really react to any kind of frequency. There's nothing going on, as you can see, and that becomes really difficult. I mean, okay, there's more light coming up, but yeah, it's coming more. So we are at the moment at 16 kilohertz, getting brighter. Now let me find a better way to display that. Right, 1 input side, 1.5. Look at that, voltage is dropping dramatically. It drops dramatically. It's a tenth of the voltage we had before at 29 kilohertz. However, we have at the moment around 15.3 watt input, and okay, and duty cycle is quite high. Did it deliberately. We can go lower in a duty cycle to 50. It has a small, makes a small difference. Let's keep it as that, 50% as a standard. So we have on the input side 150 volt at the moment going around. That's almost 1-to-1 to 100 volt input. We have on the output side 100 volt at the moment, peak to peak, and have on the input side about 1 amp. So that's about 150 watt currently on the input side going in, and 13.7 watt on the input side coming from the amplifier. Let's go further up in the frequency. The brightness is increasing slightly. It stays as it is, 45 kilohertz, 50 kilohertz. There is not really any kind of specific frequency response. I don't see any waves I would recognize as a tuned or resonant wave currently. Let's recycle it again. There were sharp drops. So when the voltage goes up here, the current drops. So at that same moment, that's quite interesting actually. So we have a long gap where nothing happens. So when here the voltage is 0, the current drops from top to bottom. When the voltage goes up here, there is no current, so it has no power at all here. At this small fraction here, this little line, I have the highest voltage and the highest current, and have also on the output side, that's this little green dot here. See if I can increase it a bit stronger. This green dot here, that is the current on the output side at the moment. Yeah. So that's how it looks like. That is the current on the output side. Now let's go further up. Nothing much happens here really. It becomes very static. There is no responsiveness to any change of frequency. Okay, the brightness is higher now. But what you will notice as well, of course the band is getting narrow. Because it gets narrower, there is less time of gap between the peaks. And when I go higher in the frequencies, that will be becoming so narrow that actually the efficiency of the system becomes very high. Let's see if that's the case. I'm at 100 kHz in a moment. Bear in mind that didn't work with all the other coils. They shut off at 5, 10 kHz maximum. There was nothing going on anymore. If I go higher, it stays static. Let's recycle that. That's how it looks at the moment. At 204.6 kHz. Go further up. It shortens the bands. 300. Look at that. There is no voltage at all anymore. It becomes a voltage divider. It means it's a third of the voltage we have here on the input side. Well, that is interesting, but it's also not reflected on a current. The current is also very, very low. Yeah. So I have at a moment in a coil less power, far less power, which is required to illuminate this bulb to that level. It's a similar effect as I saw it with my previous coil I did show. Let's go further up. I drop this voltage even more, but the brightness goes up. Has no impact here. It stays at the same value. 500 kHz. 20 volt. Goes more and more down. Look at that. At 586. There's almost nothing here. Brightness goes full up. What's going on? Almost looks like a short circuit, that the power from the amplifier goes directly through. At the moment 17 watt. But 17 watt is not producing this kind of illumination of this bulb. That looks more like 40 watt. If I can compare it that way. The higher I go in a frequency, the less voltage I have here. And the less current. But the brightness does not change. It goes even higher. Current does not change on the input side. I'm dropping here completely off. I assume if I go further, let's go 1 megahertz, that will be rock bottom. 8, 12 volt, 20 volt. Look at that. One megahertz. Not really much change here. We have 12 volt, 20 watt, and here is nothing on current. Absolutely nothing. And the brightness of the bulb is quite high. So, as the interim solution here, I would say, or interim result, that this configuration is not suited to take the energy out of this coil. There is a different setup required to do that. I will investigate further, but one thing is for sure, this coil does not behave like the two other coils I have tested before. Let's see what I can come up with my next tests with this coil. Thank you.